Over 2 billion people now encounter Google's AI overviews. It is injected at the very top of the interface, meaning users engage with machine-generated answers passively, by default, often without explicitly asking for them. Google defends the accuracy of this system with two architectural claims. First, that it synthesizes answers exclusively from the highest quality web results, and second, that by forcing the AI to read these specific documents, it eliminates the hallucinations that plague standard language models. To test if that is mathematically true, researchers deployed a distributed web crawler built on Puppeteer. They used a network of cloud functions to continuously fire searches at Google, capturing the exact outputs as they were generated live. Over a continuous 40-day window, this automated system issued 55,393 trending queries, spanning 19 different topical categories. For every single query, the pipeline captured the logic determining when an AI overview appeared, the metadata of the sources it cited, the factual fidelity of every sentence it generated, and the underlying code of the publisher's actual web pages. We finally have the raw data to reverse engineer how a web-scale generative search engine actually operates in the wild. This animated timeline tracks the AI overview activation rate. It holds at a steady baseline of 13.7% across all queries, but the data reveals that it spikes violently at specific chronological moments. These activation spikes map directly onto major public information events. The system overrides its standard triggering logic during moments of sudden, intense public interest. The first major surge in AI generation occurred on March 16th, driven by mass queries surrounding the Academy Awards. Another identical spike hit 4 days later, perfectly matching the tip-off of the NCAA March Madness tournament. And the highest single volume of AI responses mapped to the Artemis II rocket preparations on April 2nd. This bar chart contrasts activation by query type. While standard searches trigger an AI answer 13% of the time, that rate climbs to 64.7% the moment a user phrases their search as an open-ended question, particularly those starting with how or why. The topical data also shows intense variation. Queries categorized under health trigger an AI overview 26.6% of the time, while the system suppresses its own activation for politics and law, keeping those rates under 10%. These activation patterns reveal an undisclosed editorial layer. Google throttles the AI during sensitive political moments, but aggressively deploys it to explain health inquiries and trending news events. The general assumption across the tech industry has been that AI overviews act as a summarization layer, reading the organic links that already rank on the first page of Google and converting them into prose. This Venn diagram separates AI-cited sources from standard first-page results. The data shows nearly 30% of domains referenced by the AI do not appear in standard search results. The retrieval mechanism is decoupled, maintaining a completely separate source pool for generative AI. To determine if this separate pool is actually better, researchers scored thousands of URLs using the PC1 metric, a continuous mathematical scale that measures a domain's institutional credibility. This scatterplot maps those credibility scores. Clusters representing AI sources systematically plot higher on the y-axis than standard search results. The widest gaps appear in strict informational categories. For science, business, and finance, the AI source pool is demonstrably more credible. The AI achieves this higher credibility score primarily by applying a harsh filter against unvetted user-generated content. Sites like Reddit, Instagram, and TikTok see a 27% reduction in visibility within AI citations compared to organic search. By suppressing forums and social media, the mathematical average of the AI source pool rises, prioritizing established institutional reporting. Google's generative layer pulls from higher quality sources. However, because this retrieval system operates in isolation, the publisher providing the definitive answer to the AI is often entirely excluded from the organic ranking economy happening below it. Vetting the sources is the first stage of the audit. To test the system's accuracy, researchers verified the actual text the AI generated by extracting 98,020 individual factual claims and verifying each against the cited documents. At a baseline level, the grounding architecture works for the majority of queries. Nearly 89% of the AI statements are consistently supported by the attached references. This chart tracks the remaining 11% failure rate across query categories. Omission is the primary failure mode, with 7% of generated claims absent from the cited source. More severe are explicit contradictions, where 2.7% of claims directly oppose their cited reference. This scatter plot maps source credibility against factual fidelity, plotting a completely flat, non-correlated trend line. There is zero relationship between input reliability and output accuracy. Feeding the model highly vetted journals doesn't lower hallucination probability. Errors are a structural reality of the generation layer. This is the grounding paradox. Even with high-quality retrieval systems filtering the web, an 11% ungrounded claim rate acts as an immovable architectural floor for current language models. When we shift our focus from the text the AI generates to the underlying code of the websites it reads, the economic consequences of this architecture become visible. By parsing the DOM structure of the 60,000 cited reference URLs, the crawler detected display ad trackers. Over 50% of the publishers supplying the AI's answers rely on page view advertising to survive. That exposure is concentrated in massive consumer categories. 60% of the sports websites and 55% of the entertainment websites consumed by the AI require human traffic to generate revenue. Generative search acts as a terminal filter. It reads the publisher's work, synthesizes the correct answer, and presents it directly to the user, halting the click-through required to trigger a publisher's ad impression. But while the publisher loses their monetization opportunity, the host platform does not. In this wireframe of the actual search results, Google's own sponsored search inventory survives the generative process. In the highest value queries, platform ads are positioned directly above the AI overview block. This creates an absolute economic asymmetry. Independent publishers supply the high-fidelity context for free and absorb the resulting traffic loss, while the search platform preserves its own ad inventory on the exact same page. The audited data paints a dual reality. Google's AI overview successfully suppresses unvetted social media, prioritizing highly credible institutions far better than its own traditional search engine. Yet despite that high-quality input data, the generative model still breaks down, stating contradictions or complete fabrications 11% of the time. By satisfying the user's query without requiring a click, the system actively degrades the financial incentives for the publishers creating the data. Without those independent publishers investing in real reporting, the AI loses the credible inputs it requires to function. It required a massive deployment of automated servers just to extract a 40-day snapshot of this behavior. Google continues to expand this system as a black box, offering no transparency into its trigger logic or its failure rates. Google has transitioned from a directory of sources into an automated author of knowledge. The platform now actively mediates information by interpreting the web on behalf of the user. The digital ecosystem is currently forced to subsidize a zero-click synthesis engine. The margin of algorithmic error is structural, but the financial cost is entirely externalized.